and we see that we have solved 21, actually 22 problems, and today we are going to continue solving more problems. I'm a little tired today, so I'm not entirely sure how many problems I'll be able to solve, but let's see whether we can solve like one or two. So we start with problem 22, and it talks about names, name scores. Okay, so let's create a new notebook and call it problem 22. So this is called problem 22, and let's copy the problem over here. Problem 22, and it's called name scores, like that. And now let's copy the problem. There you go. Okay, so what is the problem? Using names.txt, right click and save blah blah blah. Okay, so there is a hyperlink over here. Copy link, and I should do that. I should do that. Okay, right click and save a 46K text file containing over 5,000 names. Begin by sorting it in alphabetical order, then working out the alphabetical value of each name, multiply the value by its alphabetical position in the list to obtain a name score. Okay, so let's do this first. Let's I think we should be able to just curl it. Be able to just curl it like that. Oh, okay. And I will put it in names.txt. Okay, and if I do a ls over here, there is this file called names.txt, so we have it over here. Okay, let's read it. So it is 46K, yeah, so it will, I have 32 gigs of RAM, so I don't think I will run out of memory. Names.txt, text as f dot read data. I think this should be everything. Yeah, that's the string. And we want to first of all, yes, we want to split it first, and so let's do that. Data dot split, and we want to split by that. So what happens? So that is going to give us all of this stuff, and data is that, and let's look at data. The first one and the last one will probably have something funny. So we have to change them. So data 0 equals 0, 100, and minus 1 is data minus 1 all the way up till minus 1. And if I look at this now, I will see that we have what it is that we need. So if we look at data now, it is going to be this big list. There are 5,163 names. Okay, and let us sort this. Data is sorted data. Okay, it looks like it is sorted now. So we have done the first part. Contains over 5,000 names. Okay, begin by solving it in alphabetical order, then working out the alphabetical value for each name, multiply the value by its alphabetical position. For example, Colin would obtain a score of, it's 938 probably. Okay, so let's look at data 938. I think it will not be Colin. 939 is, wait, 937 Colin. Okay, so it's one more than the ith value because it's 0 indexed Python. Okay, and now we have to find alphabetical value for each name. So C, for example, is 3. Okay, so for this, let's call this D, where D is Colin. We want to find a function that okay, -67 minus 64 is 3. Yep. So that means the lexicographical, wait, what the hell is this? Alphabetical order. Alphabetical value for each name. So the alphabetical value for each name is something that looks like this. So in case I have Colin, the value will look like, I'll just call this name, and for character in name, I need the ORD of C minus 64. I think that is 3 plus 15 plus 12 plus 9 plus 14. And if I take the sum of this, That's 53. So I just need to find the sum of all of this. So this should be fairly simple. For name in data, and I also need the position I, and name in numerate data. Okay. Total equals 0, and S for sum. Okay, and I want total first equals I plus 1, because the first one needs to be 1 or 0. Multiplied by S, and we are going to get a value of total, if I can spell it correctly, of that. Let's see whether we get it right. Okay, this was a fairly simple problem. So we have solved problem 22. Let's look at problem 23. Okay, so that's 22. Now let's look at the next problem. I don't know what this is. Oh, sorry, this is the one that I just opened. And let's look at problem 23. Non-abundant sums. Okay, let's just copy this first, and let's look at this. This is problem number 23, and this is problem 23. All right. So what's the problem? A perfect number is a number for which the sum of its proper divisors again, I think we did a problem on proper divisors. Okay, sum of its proper divisors is exactly equal to the number. For example, the sum of proper divisors of 28 would be blah blah blah, which means that 28 is a perfect number. Okay, perfect. A number n is called deficient if the sum of its proper divisors is less than n. Okay, deficient. Okay, and called abundant if this sum exceeds n. Okay, as 12 is the smallest abundant number, so like 12, 1, 2, 3, 4, 6, the sum of that is 16. Okay, the smallest number that can be written as the sum of two abundant numbers is 24. So that is 12 and 12. Sum of two abundant numbers. Okay. By mathematical analysis, it can be shown that all integers greater than this value can be written as the sum of two abundant numbers. So that's an important number. Okay. However, the upper limit cannot be reduced any further by analysis, even though it is known that the greatest number that cannot be expressed as the sum of two abundant numbers is less than this limit. So find the sum of all the positive integers all the positive integers which cannot be written as sum of two abundant numbers. Okay, many things to solve over here. Number one, find the number. Okay, that's number one. We need to find the proper factors of a number. Number two, find if a number is an number. Number three, find all numbers till that value. Okay, number four. Okay, find look through the numbers to find. Okay, all means a list of all abundant numbers still there. Loop through the numbers. Okay, loop through the numbers to find whether the number can be composed of two numbers. The of these is the answer. So these are all the things that we need to do. Oh no, the sum of all positive integers. Okay, the sum of these is the answer. Okay, let's get to work. Find the proper factors of a number. Def per factors given a number n equals factors is an empty list. It starts with 1. For we can start with an empty list. For I in range, I can start with 1 and 1, 2 to n by 2 plus 1. Okay, if n percentage I happen to be 0, and I. Okay, and return factors. So that's number 1. For example, 12 factors 12, proper factors, like that. Okay, 1 2 3 4 6, 1 2 3 4 6. Okay, how about 13? Very good. 25. 1 and 5 squared. 27 139. Okay, so this is okay. Proper factor sum. I need the sum of that. Proper factor sum is return sum per factors, sum proper factors n. Okay, so we have a way of find whether a number is abundant. Def abundant like that, n, and that would be true if n return n is greater than sum. Okay, so we can find if a number is abundant. For example, abundant 12. Wow. Proper factor sum. Is not abundant. N should be less than, and 11 false. 20. Okay, let us see. For I in range 2 to 20, print I and proper factors. What the hell is that? Okay, interesting. Okay, next, what do we have to do? Find a list of all abundant numbers till here. So I need to go till this plus 1 and numbers is that, and if abundant I so how many many do we have? That many abundant numbers. Okay. Executed in 2 milliseconds. I'm surprised. It looked like it took more, but anyway. The smallest number that can be written as the sum of two abundant numbers is 24. Okay, so for I in range 24 to 50, I need to check if there is a number, the two of these numbers can add up to, so let's start with 21. Okay. Okay. So this number I this should be an abundant number. So then some I also want to append G and I minus G. Okay, and let's look at sum 2. So 24 is the first abundant number. It comprises of the numbers 12 and 12. So I should break. Why am I getting a different set of numbers if I do this? Oh, I'm getting repeats. Yeah. So this is better. So 24 is the first abundant number that can be run. Smallest number that can be written as sum of two abundant numbers. So like that, and then we have to find all integers greater than this can be written as odd-to-even numbers. Okay, so I just need to go all the way up to here. I don't need to check this here, and I just want to append I. Might as well put +1. Okay, and if I import a TQDM, I have, if I do TQDM, I should be, I should be multiprocessing that. Oh, look at that. It's multiprocessing by itself. I like it. Interesting. It is multiprocessing by itself. Probably, I don't know. Let me see. Oh, Firefox. Never mind. My bad. A minute. I am pretty sure I'll be able to I'm pretty sure I don't have to do this. It's gonna finish fast, that's not a problem, but I just need to find all commutations of this. I'm probably doing too many computations. It's 3 minutes. So I have a list of numbers. Sanity check, 24 is the first of them. How many are there? That many. So here I'm trying to figure out all the rest of the numbers, so which cannot be written. What am I doing? That many, only that many. These all, yeah, these are correct. Two 20161. Okay. Sum of the rest is that number. Okay, so that is the solution for problem number 23. Okay, so let's stop over here. Let's look at our progress. We've solved problem 23. Maybe tomorrow I will solve 2 more. Yeah, in this week I aim to finish till 30. Okay, so what is this? Okay. Never mind, I don't know what this is. So thank you for watching. I will as always upload this to YouTube. If you are watching this on YouTube, please like and subscribe, and I will see you next time. Bye bye.